Hello, I am Lucio Andreani, coordinator of the PhD in Physics at the University of Pavia. Let me first say that our PhD program is officially in English. All our lectures, seminars, colloquia and common activities are held in English. What is our mission? We believe we have three goals. The first goal is to train our graduate students to perform innovative and high-level research in a given area of either pure or applied physics. Our PhD students have a number of research opportunities at the physics department, at the INFN, the National Institute for Nuclear Physics, and together with our partner institutions in Italy and abroad. The second goal is to give our graduate students a feeling of research in all areas of physics. Of course, a doctor in physics should become specialist in his or her own field of research, but they should also be conversant in all areas of physics, and we believe they should also be able to communicate their results not only to specialists, but also to physicists from any other area, and also to the public, as dissemination and communication of results is becoming a very important part of the job of any scientist. The third goal is to provide our graduate students with a set of skills that can be spent in any professional environment. Such abilities are called transferable skills in European language, and they are those which promote independence and workabilities. This is actually very important, as the outcome of the PhD is not necessarily a position in a university or research center, but it can be a job in other sectors like industries, medical centers, finance, consulting companies, software companies, teaching or public administration or whatever. Now, the kind of training which is characteristic of the PhD in physics is focused towards problem solving. It requires teamwork in international context, and this gives professional abilities which are usually appreciated in many contexts. Now, coming to our areas of research. They are, let's say, four. First one is physics of matter. This is experimental and theoretical solid-state physics, including semiconductors and nanostructures, insulators, magnetism and superconductivity, correlated systems, optics and photonics, nonlinear optics, and quantum optics. Another second area is theoretical and mathematical physics. This includes nuclear physics, particle physics, general relativity and cosmology, statistical physics, mathematical methods, quantum information science, and foundations of quantum mechanics. The third area is nuclear and subnuclear physics, experimental nuclear and particle physics at various energy scales. And these activities are conducted, of course, in collaboration with large infrastructures and big laboratories like the Gran Sasso Laboratory in Italy, the CERN at Geneva, the Fermilab at Chicago, and many other large facilities all around the world. And we promote also research in astrophysics. A fourth broad area of research is what we call interdisciplinary and applied physics. This includes biomedical physics, renewable energies, photovoltaics and energy storage. It includes econophysics. This is the statistical analysis of financial systems, and ICT, information and communication technologies. Let me say a few more words about biomedical physics, because this is a very important area of research which is growing and with a strong impact on society. We rely on local facilities like the CNAO, the National Center for Hadron Therapy of Tumors, the LENA nuclear reactor, which is a source of neutrons for BNCT, boron neutron capture therapy. Then we have strong activities in radiobiology, and also strong activities in nuclear magnetic resonance, which becomes magnetic resonance imaging in biomedical context. Now, we feel there is no real distinction between pure and applied physics. It is often the same groups which promote both directions of research. And applied physics provides cultural challenges and also very good career and funding opportunities. International. Our PhD has been recognized as international doctorate since about 15 years. We have many international agreements signed with partner universities in the United States and Europe. We encourage our students to spend part of their PhD research work abroad in the framework of such international agreements or of special co-tutelle thesis agreement, or also in the absence of such agreements, our students are strongly encouraged to spend part of their PhD abroad. So finally, if you are interested in our PhD, if you applied and you will be admitted, it will be our pleasure to help you and support your research, and also to help you in building up your own career development plan for the next 3 years and perhaps even more.
My name is Piotr Kowalczewski. I come from Poland, and I've recently completed my PhD in physics here at the University of Pavia. I participated in European Marie Curie training network, where 14 young and enthusiastic researchers worked on controlling the light at the nanoscale for a number of applications like medicine, gas sensing, solar energy, and communication. The network was a strongly international and diverse team where PhD students had an opportunity to travel a lot, share their work, and learn from the very experts in the field. So I think Pavia is a great place to do your research, meet new people, and pursue your own aspirations.
Hi, I'm Barbara de Palma. I'm a PhD student at first year. My research focuses on quantum field theory and hadronic physics from a theoretical and numerical point of view. I attended the bachelor and master degree at University of Pavia, and I've chosen again Pavia because I'm deeply convinced that it is an excellence, and because it will me give the possibility to perform high-level research in a European and global context.
Hi, my name is Ilaria Vai. I'm a PhD student in physics at the University of Pavia in the field of high-energy physics. I work in the CMS experiment, that is one of the big experiments at the LHC at CERN. I'm working in CMS since my master degree, and then I'm continuing my work during my PhD. One of the most important characteristics of this big experiment at the LHC that I have appreciated a lot for my personal experience is the fact that these collaborations are made of thousands of people that comes from all over the world. This fact gave me the possibility to interact and work with people coming from different countries with different habits and different way of thinking. So if you are interested in sharing your experience with people with different cultures, the University of Pavia and the PhD in physics is the right solution for your future.
Hi, I'm Ian Postman and I'm a third-year PhD student here at the University of Pavia. My research subject is biomedical physics. In particular, my field is BNCT, which stands for boron neutron capture therapy. My work was done here at the University of Pavia at the Lena Laboratories, which is a nuclear power plant, but also in other laboratories in Italy, like the ENFN laboratories of Legnago, and also abroad, like in Argentina, Japan, and Finland. In these 3 years, I also managed to present my work in different international conferences, and therefore I recommend to do the doctorate in physics here in Pavia to those that are interested in physics, but in particular to those that are interested in biomedical physics.